Algebra 2, Lesson 3-1, Solving Systems Using Tables and Graphs. A system of equations is a set of two or more equations that use the same variables, like 3x plus 2y equals 5, and 2x minus 7y equals 11. That would be a system of equations. A linear system is the graph of a system of equations that is a line. Linear comes from the root word line. The solution of a system is the set of values for the variables that makes all the equations true. All of the equations true at the same time. Now, a system of equations can be classified by the number of solutions that it has. A consistent system has at least one solution. At least one. Could be more than one. Okay? There could be two lines that cross in one spot. That would be a consistent solution. An independent system is a system that has a unique solution. That means it really only has one solution. Two lines intersecting one point. It's independent. If it is independent, it must be consistent. It falls into that category. A dependent system is a system that has infinitely many solutions, which means it has so many you can't even count them. Okay, so it's an infinitely many solution system. Okay, and if it's a dependent system, that also makes it a consistent system, because it has at least one. If it has infinitely many, it has at least one. An inconsistent system is a system that has no solution. And we're going to talk about all these types of systems a little bit later in this lesson. Moving on. To solve a system of equations, find a set of values that replace the variables in the equation and make each equation true. One of the ways you can do this is graphically. The second way you can do this is by making a table. I find that graphically is easier on some respects, and making a table is easier on other respects. We're going to do both of them for the same example so that you can see which one you prefer. Okay, let's take a look at this first example. Let's say we have the following system. X minus 2y equals 4 and 3x plus y equals 5. The first way I'm going to solve it is I'm going to solve it by graphing. I'm just going to simply solve these for y, put them in y equals form, graph the equations, and find out if they have a unique solution. So the first thing I'm going to do is I'm going to solve each equation for y. Okay, so I'm going to have negative 2y equals negative x plus 4. Divide everything by negative 2. That would give me y equals 1/2 x minus 2. That's my first equation. In my second equation here, this is equation 2, this is equation 1. My second equation, I will have y equals negative 3x plus 5, because all I have to do is move the 3x to the other side. So now I have two equations in slope-intercept form, so that they're easier to graph. I'm going to graph them on this set of graph paper here. There's an x-axis, there's a y-axis. So how's the graph? Number 1, y equals 1/2 x minus 2, go down 2. My slope is up 1 over 2, up 1 over 2. Graph this line. It's very important that you use straight edge for these and can carry them beyond your points, because if you don't carry the line beyond your point, if it doesn't intersect exactly where you drew it, you're going to have to draw it again to get it to intersect later on. So here we have that equation. The easiest way to label these equations is to just simply label them by a number. There's equation number 1. Equation number 2, y equals 3x plus 5. I'll go up 5. 1, 2, 3, 4, 5. Negative 3 is down 3. 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. I'll look at it. It's going to intersect at the point right there. So if I was to draw this graph, again, make sure the line is straight. Going to your points. Of course, always label this so that we know which graph is which. This happens to be graph number 2 for me. So I'm going to label this here 2. And if we can see that it intersects at this point right here. That point happens to be 2, negative 1. So the solution of this equation is 2, negative 1, which makes this both a consistent system and an independent system. It's consistent because it has at least one solution, and it's independent because it has a unique solution. That's the only solution. 2, negative 1 is the only solution that works for this. Now, if we wanted to solve this using a table, again, I'm going to use the same equations. I'm going to use them in y equals 1. So this would be y equals 1/2 x minus 2. And this one would be y equals negative 3x plus 5. And I already know what my solution is, so you might be a little tainted by that. If you didn't, I would start with like -2 and go from there. And I'm going to do that. I'm going to start with -2, then go -1, then go 0, and then 1 and 2. And I'm going to solve them separately. In the first equation, which I would call y1, okay, if I was to put in -2 for x, half of -2 is -1, -1 minus 2 is -3. If I put in a -2 in the second equation, I'm going to get 6 plus 5, which is 11. If I put in -1 for this first equation, I'm going to get -1/2 minus 2, which is -2.5. If I put in -1 in the second equation, I'm going to get 3 plus 5, which is 8. If I put in 0 for the first equation, I'm going to get -2. If I put in 0 for the second equation, I'm going to get 5. If I put in 1 for the first equation, I'm going to get -1.5. If I put in 1 in the second equation, -3 plus 5 is 2. If I put in 2 for the first equation, I'm going to get half of 2 is 1. 1 minus 2 is -1. And if I put in 2 for the second equation, I'm going to have -3 times 2 is -6, plus 5 is -1. Now I know this is the solution because as soon as I get a pair of numbers that are exactly the same for the same x value, I've got y1 equals -1 and y2 equals -1. Since both of those ended up to be the same value for my x value of 2, I know that's the solution to my equation. So that's how you can use a table. You can also use a table using your calculator. It's a little bit faster because they'll do it for you. You still just need to put your equations into your calculator in y equals form, and then go to the table set. And I'll show you how to do that in class. All right, let's take a look at another one. We're going to do this one using a table, because sometimes it can get really obnoxious to try to do this using a graph. Okay, using a table to solve a problem, you're going to define your variable, define your equation, and then you're going to use the table to solve the problem. List your x values until the corresponding y values match. And this is probably where I'm going to show you how to do this on the calculator. I'll try to walk you through it. At least on the TI-84, I'll walk you through how to do it on the calculator. All right, so you want to buy a camera. A film camera costs $89.98, and each photo costs 24 cents. A digital camera costs $124.48, and each photo costs 9 cents. After how many photos will the overall cost of the cameras be the same, and what will that cost be? Right? Okay, so first thing I'm going to do is I have to get variables. I have a film camera and I have a digital camera. So we know that we have two different types of cameras, but we also know we're going to have a total cost. We also know that each photo cost is different. So that's probably what I'm going to set up my variables. And I know that my number of photos is independent. Okay, my number of photos doesn't depend upon the cost. My cost depends upon the number of photos that I take. Since cost depends upon photos, I'm going to let x equal my number of photos. And y is going to be my total cost. And then we're going to have a cost for the digital camera, and we're going to have a cost for the film camera. So for the film camera, my total cost will be the price of the camera, which was $89.98, plus it costs 24 cents per photo, 0.24 times x. So my total cost is going to be the cost of the camera plus the cost of each photo. For my digital camera, same thing, I'm going to have a cost. My cost is going to be $124.48. But it's only going to cost 9 cents per photo. Okay, so we now have our two equations. If I was going to put these in my calculator, for the TI-84, and you have the Inspire, I may have to walk you through that in a slightly different way. But for the TI-84, the first thing you're going to do is go to your y equals key. All right, your y equals key, and you're going to set up two equations. an equation 1 and equation 2. So you're going to go to your y equals key, make sure that the plots are off at the top. Under y1, you're going to put down 0.24x plus 89.98. And for y2, you're going to put down 0.09x plus 124.48. You're going to put both of those into your calculator. My first one and my second one, 0.09x plus 124.48. I'm going to put both of those in. I'm not going to graph them. I'm going to immediately go to the table. Now, with your table, you can do something called a table set. If you look at the row of keys that are at the very bottom of your screen, but before you have the major functions of your keys, you have a y equals key, then you have a window, a zoom, a trace, and a graph. Above the window key, you'll see the blue lettering that says TBL set. That's your table set. In order to get to anything in blue, you have to hit the second blue key. So I'm going to hit that second key and the table setup. The table setup tells you what number you're going to start with and what are you going to count by. Okay? And I know it's going to take quite a few pictures to get these to be fairly equal. So I'm going to start with about, let's say, 100. So I'm going to start my table at 100, and I'm going to go by ones because you can't have half a picture. And once I've set that up, the independent is auto, the dependent is auto. So now I'm going to go to my table, which is above the graph feature. So hit the second graph feature, and that'll get you to your table. It'll say X, and then we'll have a Y1 and Y2. And right here at X, okay, at my table right now, I have an X, and I have a Y1, and I have a Y2. At my table, when X is 100, my Y1 says $113.98. That's what it's counting for. And this one's 133.48. So they're fairly far apart. So I know I'm going to have to go for a while. So I'm just going to scroll down. I'm going to scroll down until I can see them. You know, they're getting closer and closer together because when I get to, let's go say to 150. At 150, my Y1 is 125.98. And my Y2 is 137.98. So they're getting closer, but you can still see they're quite a ways off. So I'm going to scroll down again. I know I have to go quite a ways to do this. I'm going to go down. I'm going to go all the way to 200 before I look at it again. And when I get down to 200, I can see that I have, at 200, I have 137.98 for Y1. Oops, 98, not 88. And for Y2, I have 142.57. So they're getting closer, but they're still a ways away, so I'm going to have to keep scrolling down for a little while. I'm going to check it every 10 now. At 210, 140, nope, they're not. Hey, let's look at 220. Getting closer. Alright, so let's just say I start with 225. Okay, 225. I have 143.98, Y1, and 144.73 for Y2, so they're getting closer. Let's see here, what happens if I have 226? 226, 144.22, and 144.82. I have 227. I have 144.46. We're getting much closer. 144.91. I have 228. 144.70. And 145 even. 229. There are 144.94. And 145.09. And 230, well, looky there, 230, 145.18, and 145.18. So there we have it. We did our table. And normally I wouldn't put that many values in the table, but I was trying to show you how it works. So the question asks us up here, how many photos will the overall cost of the cameras be the same, and what will that cost be? at 230 photos. Cost will be equal at $145.18. There you go. Okay. Now, another really cool thing we're going to do is we're going to talk about linear regression. Here you have to use your calculator. There's no other way around it but to use your calculator for linear regression. Again, I will have to show you in class how to do this again. I'm going to only do it on the TI-84 for right now. For those of you who have the Inspire, I would highly suggest that you Google how to figure out how to put linear regression in, because it'll be similar to the keystrokes that I use on the 84. I haven't quite learned all the keystrokes yet. I'm still working on that myself. So it's something that you should probably get very familiar with, and I will show you in class because I'll have it down real quick. All right, so it says, use the table shows the number of pairs of shoes sold by 2 new employees at the shoe store. Find linear models for each employee's sales. Use the graph of the models to predict the week in which they could sell the same number of shoes. Right? And it's not too hard to use. What we're going to do here is we have let x equal our number of weeks, because the number of weeks is independent and the number of shoes is dependent. The number of shoes they sell is dependent on the number of weeks that they sell shoes. We're going to use the linear regression feature of your graphing calculator to find the linear models. So basically what I'm going to do is the number of weeks is L1, the number of shoes for Ed is L2, and the number of shoes for Joe is L3. So I'm going to put these in my calculator. So to do that, you turn your calculator on, go to Stat, and you're going to edit it. It's the first thing that comes up. The edit key is highlighted. You're going to hit that. You're going to make sure there's nothing in any of your L1s, L2s, L3s. If there is anything, go up, highlight L1, hit clear, hit enter. It'll go away. Do the same thing if you have anything else on any of the other L1, L2, and L3 screens. Then for L1, I'm simply going to put 1, 2, 3, and 4. So hit 1, enter, 2, enter, 3, enter, 4, enter. Scroll over to L2, put 50, enter, 55, enter, 63, enter, 67, enter. And then for L3, you're going to put 40, enter, 47, enter, 56, enter, 62, enter. Make sure all your data is correct. I always read through it again to make sure that I didn't mess anything up on my keystrokes. Once you've done that, now we just need to use the linear regression key. So we're going to get out of that, hit second click, go into your y equals. Now we need to make sure there's nothing in the y1 or y2 keys. Make sure y1 equals and put nothing. Go up there and hit plot 1. Make sure that it's on. Okay. And then we could, what we're going to do here is now we're going to go back to your stat key. So you're going to go to stat again. And this time we're going to calculate it. And you're going to go down to linear regression, which is number 4. Okay, actually, let's do this. Let's not do that. Let's just go to your y1 key. Okay. Actually, no, let's calculate this. I was wrong right the first time. Go to your stats key, go to calculate, go linear regression, which is 4. For your x list, put L1, and for your y list, put L2. So this is going to be, because there's going to be 2 equations. There's going to be an equation for Ed, and there's going to be an equation for Joe. Okay? And Ed is L2 and Joe is L3. Everything is going to be, so for Ed's equation, for your x list, you're going to put L1, and for your y list, you're going to put L2. Okay, and make sure that's there. And then you're going to, then go all the way down to the bottom and hit calculate. And when you do, you're going to get y equals ax plus b, and they're going to tell you a is 5.9 and b is 44. So I'm going to do that. So I have y equals ax plus b. It told me that, where it told me a is 5.9 and b is 44. Which means Ed's equation then is y equals 5.9x plus 44. That's what Ed's equation is. We're going to go back and do the same thing for Joe. So hit your stat key again, scroll over till it says calculate, go down to 4 where it says linear regression. Make sure your x list for Joe is L1, but your y list for Joe has got to be L3 this time. So go down there and make sure it says L3. And if you don't know how to put that in there, it's in the blue. So second 3 pulls up L3. And you're going to calculate that. And that's going to give you an A of 7.5 and a B of 32.5. So Joe's equation is y equals 7.5x plus 32.5. So those are the two equations we now need to put into our calculator. So now go into the y equals. Make sure your plots are off. I messed that up earlier. So highlight and make sure your plots are not highlighted. Go to L1 and you're going to put in 5.9x plus 44. And then go into L2 and put in 7.5x plus 32.5. And then you're going to graph these. And they may not come up where you can see them where they're going to cross. If that's the case, what you're going to want to do is you're going to zoom and you're going to go down to fit. You hit zoom fit and they both should fit on the graph and they'll cross at some point. Okay? And then what you're going to do is the easiest way to do this now is you're going to hit second calculate, okay, which is up on your blue keys. There's your calculation keys right underneath your screen. That's right above your trace. So second trace, you're going to calculate where they intersect, which is 5. Okay? And it's going to say first curve, and it brings up the first equation. And you're just going to hit enter. And it's going to hit second curve, and it's going to bring up the second equation. You're just going to hit enter. And it's going to say guess with a question mark. You're just going to hit enter again. So you're going to enter 3 times. And it's going to say your intersection then is, it's going to put in your calculator, intersection is x equals 7.1875 and y equals 86.40625. So there's your intersection of those two numbers. Okay. So to solve the equation, the equation says, okay, use the graph of the models to predict the week in which they could sell the same number of shoes. So you're somewhere after the 7th week, because this is X is the number of weeks, so you're into the 8th week. So they will sell the same number of shoes in the 8th week. Okay, so the same number of shoes in the 8th week, and they will sell about 86 shoes, or 86 pairs. So somewhere during the 8th week, they will both sell approximately 86 pairs of shoes. So there you have it. Okay, let's look at the last thing here. Linear systems of 2 equations can be analyzed using the nature of the solutions. Okay, let's look at this for a second. And I've got this both in picture form and figure form. If it's one solution, it's consistent, which makes it independent. 2 lines intersect at one point. The slopes of the lines are not equal, and the y-intercepts may or may not be equal. So here's a picture of this. Here's where the unique solution of this particular equation will be. If it has infinitely many solutions, it's consistent, it's dependent, the 2 lines coincide, which in other words means they land on top of each other, which means the slopes of the lines are equal and the y-intercepts are equal. These are the things that you need to be paying attention to in these systems. The slopes are not equal here, and the y-intercepts may or may not be equal. Here, slopes are equal, y-intercepts are equal. If it's no solution, they're inconsistent, you have parallel lines. That means slopes of the lines are equal, but the y-intercepts are not equal. Okay? So that's what we're looking at. So now we can take a look at some problems and determine, without even having to graph them or make a table, whether they have 1, 2, or 3 solutions. Okay? Let's take a look at this. Okay? Classifying a system without graphing. Determine without graphing whether the system is independent, dependent, or inconsistent. Remember, if it's independent, it has 1 solution. It's dependent, it has 1 landing on top of the other. And if it's inconsistent, they're parallel. So let's take a look at this first equation here. And we have 2 equations. I'm going to number them, 1 and 2. In equation 1 here, I have y equals 3x plus 4. I put it into y equals form. In equation 2, I put it into y equals form for equation 2. I'm going to multiply everything by 3 to begin with. So I will have 3x minus y equals 3. So I will have negative y equals negative x plus 3, which means equation 2 has y equals 3x. So having a negative 2 negative 3. Minus 3. Okay? So in this first equation here, my slope is 3 and my y-intercept is 4. In my second equation, my slope is 3 and my y-intercept is negative 3. So the slopes are equal, same slope, different y-intercept. Okay? Which means they have to be parallel. Same slope, different y-intercept. These parallel lines, which means it's inconsistent. And parallel lines have no solution, which makes them inconsistent. Let's take a look at our second equation here. This is equation 1, this is equation 2. Equation 1, I will have 3y equals negative 2x plus 1 divided by 3. I have y equals negative 2 thirds x plus 1 third. That's equation 1. So my slope here, negative 2 thirds, my y-intercept, 1 third. Equation 2, I have y equals negative 4x minus 3, because all I did was move the 4x to the other side. So in equation 2, my slope is negative 4, my y-intercept is negative 3. So different slopes, different y-intercepts. Okay? Different slope, different y-intercept. Means this happens to be, the lines intersect, so this is a consistent solution. They're going to intersect in one point. And last but not least, my third equation here. Okay. Let's do the 1 and 2 again. Equation 1, y equals 2x minus 3, which means the slope is 2, y-intercept is negative 3. In the second equation here, I would have negative 3y equals negative 6x plus 9 divided by negative 3. I will have y equals 2x minus 3. Same equation. Okay, when you have the same equation, just like equation 1 and equation 2 are exactly the same, so we have the same slope, same y-intercept, same line basically. So these are dependent. So there you have it. We can solve equations by graphing, looking at a table, using linear regression, and you can also determine whether a system is inconsistent, dependent, or independent, or consistent, all based on just looking at slopes and y-intercepts.